Factorization of quadratic expressions. So this is a summary video of quadratic factorization. I plan to upload separate individual videos on the different factorization techniques, but this is assuming you've met them before and is a bit of a revision. So when dealing with a quadratic expression and when attempting to factorize a quadratic expression, the very first thing you're going to do, regardless of what it looks like, is to look for common factors and factor them out if there are any common factors. So that should always be your first step. Then you might be finished at that point. So you might have, if you had a quadratic with only two terms, and when you took out the highest common factor, if what remains in the bracket is a linear expression, then you're done. That's it, you've factorized. If, however, what remains in the bracket isn't a linear expression, but still has two terms, you might be able to use the difference of two squares. So you're looking for something squared minus something squared, and then you can factorize it using that rule. If you have a three-termed quadratic, regardless of whether it has a common factor or not, once you've taken out the common factor, if what remains in the bracket has three terms, we call that a quadratic trinomial. And it might be a simple trinomial or a hard trinomial, and I use those as loose terms to refer to. A simple quadratic is a monic quadratic, so that is the coefficient of x squared is 1, whereas a harder quadratic is a non-monic quadratic, so the coefficient of x squared is anything other than 1. And we have different techniques for factorising those. Obviously, simple is much simpler to factorise. So let's have a look at some examples. So example 1, we have two terms. Remember, the first thing we're looking for are common factors, and in this particular expression there is indeed a common factor. So 3 is common numerically, and we also have an x in common. So we should be able to factor 3x out of this expression. And when we divide 33x by 3x, we're left with 11. And when we divide negative 18x squared by 3x, we're left with negative 6x. And there's no excuses really for getting factorization wrong, because you should always be able to check it by expanding. And expanding is pretty quick and easy to do in your head. So 3x times 11, 33x, 3x times negative 6x, negative 18x squared. Good, all done. So what remains in the bracket after we took out that common factor of 3x is indeed a linear expression, and so we're complete. So example 2, we also have two terms. We also have a common factor. This time it is a common factor of 2. So if we factor that out, we'll be left with x squared minus 25. And we recognise that 25 is a square number, so this is a difference of two squares. It is x squared minus 5 squared. And if we recall our rule for difference of two squares, a squared minus b squared is a minus b, a plus b. Or obviously you can write the brackets the other way around, a plus b, a minus b. It's the same thing. So we still have our 2 out the front. You can't lose that 2, there's nowhere for it to go. But now we can factorise the bracket further using difference of two squares, and we will get x minus 5, x plus 5. And again, we should be able to check this fairly easily by expanding out. Alright, so example 3. Here we have a trinomial, so our quadratic has 3 terms. There aren't any common factors in this trinomial, so no common factors. We're straight on to identifying it as a quadratic trinomial, and in this case it is a simple or monic trinomial because we have 1x squared. So that makes it simple to factorise. So when we factorise a simple quadratic, you'll remember that the reason it's simple is because we have 1x squared, which means that the brackets must have x in each bracket, and that's what makes it simple. There are less options as to what else could be going on here. Okay, so then for the number parts of the brackets, you'll remember that in order to identify those, what we're looking for is factors of the constant term, so two numbers that multiply to give negative 28, that sum or add to give the coefficient of x. So factors of the constant term that add to give the coefficient of x. So in this case, that's factors of negative 28 that add to give negative 3. So in factorization, it is hugely important that you know your multiplication tables. It makes life so much easier and so much quicker if you can straight away look at 28 and think, oh, 28 is 7 times 4. Oh, hang on, that's going to be useful. So we're definitely going to have 7 and 4. If they're to multiply to give negative 28, one is going to need to be positive and one is going to need to be negative. And if they're to add to give negative 3, we will need the bigger one to be negative. So we need negative 7 and positive 4. And we're done. Again, check it by expanding. Example 4, again, no common factor, simple quadratic trinomial. So we should be able to straight away write down our answer. In this case, we are looking for factors of positive 56 that add to negative 15. So I'm thinking, well, 56, that's 7/8 of 56, or in 7 and 8 should be able to add to add to 15. Oh, sorry. But we want them to add to negative 15, so we're going to need them to both be negative. So negative 7 plus negative 8 is indeed negative 15, and negative 7 times negative 8 is indeed positive 56. Again, check it by expanding it. Okay, so in example 5, we have, remember our first thing that we check for is common factors. And in this case, we do have a common factor. So we actually have a common factor of 3. So the first thing I'm going to do is take that out. Always take out common factors. They might make this quadratic, which initially appears to be a hard quadratic, actually no longer a hard quadratic. So if we take out 3, we'll see that that does in fact happen here. We'll be left with x squared plus 7x plus 12. And actually what looked like a hard quadratic at the beginning is really a simple quadratic. So now we can factorize the simple quadratic in the brackets. We're looking for factors of positive 12 that add up to positive 7. So that's positive 3 and positive 4. Alright, example 6. So again, it's a trinomial. This time there aren't any common factors. So we are stuck with this 2 in front of the x squared, which means that this is a hard quadratic. Now there are a number of different ways for solving or factorizing harder quadratics. Most people use a trial and error method. They call it the cross method, but the cross is really just a way that you can set out your trial and error. It's essentially trial and error. I prefer not to use the cross method. I use a different method, which sometimes seems a bit more complicated, but once you get the hang of it, it's actually very quick and efficient. And what I find is students find it easy because it doesn't involve that trial and error kind of method. There's a series of steps that you follow and you'll get to the answer every time. So it's purely a matter of preference, and if you have a method for solving or factorizing harder quadratics that you use and can use well, go ahead, continue to do it as you would do it. But I'm going to show you my method here. So what we do is we take the coefficient of x squared, which is 2, and we multiply it by the constant term, which is negative 36. So we're doing 2 multiplied by negative 36. So that gives us negative 72. Okay, then what we want to do with the negative 72 is we now want to look for factors of negative 72 that sum to the coefficient of x. So we're looking for factors of negative 72 that sum to give positive 1. So again, you need to know your multiplication tables. I know 8 times 9 is 72. If they need to add to give positive 1, I'm going to need negative 8 and positive 9. Okay, I'm just going to rewrite out my quadratic here, just so I've got a bit more space. Alright, so now what I want to do is I want to take these two numbers that I've just generated here and I want to rewrite the x term or the middle term using these two numbers. So instead of having just plus x in the middle of my quadratic here, I'm now going to break this up using the two numbers I've just identified. So I'm going to rewrite it as negative 8x plus 9x. So we're not changing anything here. These still add up to 1x. We're just rewriting it in a different way. So it's still exactly the same statement. Okay, so now what I want to do is I want to use factorization by grouping. And you may have seen this before. But when we factorize by grouping, we're going to take this 4-termed expression and break it up into two 2-termed expressions. And we're going to treat them separately. So we're going to look at the first 2 terms only and look at factorizing them, so by taking out a common factor. So 2x is common here. And when we take out 2x, we'll be left with x minus 4. And then looking at the second 2 terms, the highest common factor there is positive 9. Don't forget the operation symbol in the middle here. If you leave it out, you're implying that you're multiplying by 9 here, and that's not what's going on here at all. So positive 9 is the factor, which means it's going to be plus 9 multiplied by When we take positive 9 out of here, we're left with x minus 4. Now at this point we know that we're on the right track, or we've done everything correct so far, because these brackets are the same. If these brackets aren't the same at this point, you've done something wrong. You've chosen the wrong numbers, you've not factorized correctly, whatever it might be, something has gone wrong. Okay, so now we've got these brackets the same, and that's important because this bracket now becomes the common factor. We're going to take out x minus 4 as the common factor. And we take x minus 4 out, we're going to be left with 2x plus 9. And there's your factorized expression. And again, check it by expanding it out. X times 2x is 2x squared, x times 9 is 9x, and negative 4 times 2x is negative 8x, so 9x minus 8x is indeed 1x. Negative 4 times 9 is negative 36. Okay, example 7. Again, no common factors, 3 terms, harder quadratic because of the 12 in front of the x squared. So we're going to use this same method again. So we're going to do 12 multiplied by negative 5, which is negative 60. Don't miss the negatives attached to the coefficients. And we're now looking for factors of negative 60 that sum to give positive 17. So we're going to have 20 and 3. We're going to need negative 3 in order to make 17. And so now we're going to rewrite our quadratic by breaking up 17x. So instead of having 17x in the quadratic, we're now going to have 20x minus 3x. We've obviously still got the other terms around that. It's still the same expression, just written in a slightly different way. So now we want to factorize by grouping. So we're going to split the quadratic in half. So common factors in the first 2 terms. 4 is common and x is common. So when we take out 4x, we'll have 3x plus 5. And in the second 2 terms, now there's no, well, 3 and 5 don't have common factors apart from 1. But what we need to remember here is that the important thing is that the brackets at this next stage are the same. So in fact, to make the brackets the same, I need to factor out negative 1 here. So if I take out negative 1, I'm going to have 3x plus 5 in the bracket, which now means same thing. So we can take out 3x plus 5 as the common factor. And when we do that, we're left with 4x minus 1. Again, you can check it by expanding. Okay, now last example here, we wish to factorize 108 plus 3x minus x squared. So the first thing I recognize here is that my quadratic isn't in a standard form, if you like. So you need to write your terms in decreasing powers of x. So put the x squared term first, then the x term, and then the constant, just so you can be clear about what's going on here. So now we see that we've got no common factors, we've got 3 terms. This isn't a simple quadratic because we don't have just 1x squared, we have negative 1x squared. And so this is a bit of a problem. But while I said before that there aren't common factors, we could treat negative 1 as a common factor. And if we took negative 1 out, we would now have x squared minus 3x minus 108. And so now we do have a simple quadratic, just with the negative 1 out the front. Don't lose that negative 1, there's nowhere for it to go. Still part of this expression, but taking it out allows us to factorize more easily. So we have a simple quadratic, factors of negative 108, which add up to negative 3. So I'm thinking 108 is 9 times 12. So if we have 9 and 12, we need them to add to negative 3, so negative 12 and positive 9. And there's our factorized expression. You can leave it like this, that negative 1 out the front there is fine. You don't need to write negative 1 obviously, so you could just write negative x plus 9, x minus 12. The other thing you could do is you could put that negative 1 into one of the brackets. Don't multiply it into both of the brackets, then you've multiplied by negative 1 twice. Remember, if you're multiplying 3 things together, 2 times 3 times 8, for example, we don't do 2 times 3 and 2 times 8. You do 2 times 3 and then multiply by 8, or you do 2 times 8 and then multiply by 3. So same thing here when you're putting a number into brackets like this. You don't multiply that number out the front into both brackets. But I could put it into the brackets. If I put it into the first bracket, that's not very nice looking because I'll have negative x minus 9. But the second bracket, if I put negative 1 into there, I'll have negative x plus 12. So I can rewrite that as 12 minus x. So it would also be acceptable to write it like this, and that's how the answer might be given. Any of these are perfectly acceptable, but just to be aware that they're in fact the same thing. So there's a summary on factorising quadratics. As I said, I hope to upload videos on the separate factorisation techniques, but there's a summary before we now head into the next video, which will be on solving quadratic equations.